All right, hi everybody. I don't think I've actually introduced myself yet, but I'm Ben. You've probably seen me running around so far throughout the week. So I'm going to be talking about DSPy, which is a prompt compilation library. Before I get started, people in the back, is this going to be a reasonable size? Can you guys read this clearly? I need an answer. Someone in the back. Yes. Okay, cool. If it is kind of small, let me know. I'll make it bigger. So we just saw some stuff from Felipe. One of the things I want to highlight is that he was doing completely vanilla prompts, right? So all the prompts he was writing were just typing them out as strings, right, and passing them to the model. If we're going to move this sort of idea into production, that's not really sustainable, right? Anybody who's worked with just FMs in general knows how hard, like just how difficult it is to just be constantly working with prompts, trying stuff out. We sort of mentioned this already, trying stuff out, figure out what works with the model, what doesn't work with the model. And I have a software engineering background, and I hate that. Like as a software engineer, I'd like things to know what's going to happen, and the same thing is going to be consistent. And what it's sort of happening with foundation models is like vibes-based development, where you're kind of just guessing, like, oh, is this going to work? Is it not going to work? You don't really have a concrete idea of where you're going with it. And that's where libraries and frameworks like DSPy come in. So DSPy actually stands for Declarative Self-Improving Python. And it's essentially a framework for what they're trying to do is programming foundation models. So they're taking these prompts and looking at them from the standpoint of programming, right? Also I should mention, before I get too deep, everybody has access to this Colab notebook, right? And then this Colab notebook is actually based off of the DSPy docs. They have great documentation, they're really good. And then also a tutorial from a previous camp called Sky Camp. And then throughout this, there's sort of links that I've put in that sort of reference different documentation, other follow-along ideas. Jumping back in. So DSPy, Declarative Self-Improving Python. We're trying to program foundation models, right? And so it's trying to move away from this idea of, just this ad hoc writing prompts as strings, handing them to the model. Is the output good? Is it not good? You don't really know, right? And then they sort of built this framework and moved it up to include a lot of other different stuff. So we've mentioned a bunch of prompting techniques, so chain of thought, tree of thought. We're going to mention program of thought as well. There's a bunch of different prompting techniques. But these have all been sort of built in and abstracted in DSPy to make it so that you can essentially program these prompts. And we're going to see what that's like today. I will say, so this notebook, I'm cheating a little bit. So if you run this notebook without making any changes, actually all the answers are cached. So what we did was we ran this through with a good language model, cached the responses, so they'll be very quick, they'll be good. If you do want to actually get so the effect of that is that the answer is always going to be the same. So if you do want to run it and do your own hands-on stuff, I have some code that will allow you to do that. I'll do some caveats on how that actually works, but we'll get there. So like I said, sorry, let me just reconnect. So like I said, bit of cheating, right? Caching the answers. But that's what this first cell is doing. So we're basically cloning this notebook, the cache, and then bringing it back down. So once this connects, we'll be on our way. But what we're going to do here is we're just going to actually set up DSPy from the notebook. Like I said, have the cache ready to go, and we'll be good. So we've already mentioned transformers library a bit. This is what we're going to be using. Are most people pretty familiar with Hugging Face transformers? I will do a little explanation on what we mean by the caveat I mentioned, but what we're doing here is just downloading all the stuff, right, all normal, and then we'll move here once that's through. Okay. So if we're diving into DSPy, right? So what we're going to end up doing is we need an LLM for DSPy to interact with, right? So in this notebook, like I said, we're using Llama 2 13B. It's not a huge model, it's pretty old, but it gets the job done for what we're doing. Like I said, everything's cached, so we don't need any API keys, nothing like that. If you do want to run the notebook, for example, with a gated Hugging Face model, I have instructions that you can follow there. And then if you don't have an API key with Hugging Face, so you want to access a non-gated model, you can do that. It's just, none of these non-gated models are that good, so you might get a bit of garbage coming out. If you're coming through this notebook, right? So I sort of have instructions here on how to actually configure this. Basically, DSPy has a lot of instructions, or abstractions, to use, let's say, OpenAI, Hugging Face, some other ones that you might want to use, OLlama, for example. I don't have OLlama here, but it is something that you can find pretty easily. Now, if you just want to, like I said, run the notebook just vanilla, you'll be good to go, and we're going to be using this model right here. Okay, so while that all gets set up, one of the first things we're going to look at. So, DSPy, right? One of the main abstractions here is the DSPy signature. So this is what we're going to be using to represent the prompt. So in a basic LLM workflow, right, you're going to have an input, in this case, let's just say a question, that you give to an LLM, you get an output, which we consider to be an answer. In DSPy, what we do is we abstract that into a signature, which you specify as having input fields and output fields. So if we give a concrete example like that, right? So there's two ways you can write this. DSPy has a shorthand notation. So this is just the inline notation where we're going to have a question, everything to the left of this arrow, inputs, everything to the right, outputs, right? And this is how you sort of define what I would consider to be like a prompt template. And DSPy has this abstraction for different input fields and different output fields. You can also do it using the class structure, right? Same idea. You're going to have questions as an input.
Sorry, Ben, just as a question.
Yep, sure.
The answer is what you expect to be?
Yes.
Right?
So the answer, it would be what you would consider the output from the LLM to be. So if I asked a question of an LLM, I would expect an answer. You can have really this is just the name of the output you're going to give it.
It can be passed in a batch to say this is the 20 questions I have, this is the expectation of this, yeah?
Yeah, sure. Well, really it can be anything you want. So so I'll give you an example right down here actually. So in this example, right, we have, let's say, a question and context as input. So this would be what you would give the LLM. And then you would specify, okay, let's say, for example, I want the reason for why the LLM output the response it did. That's still part of the LLM answer, or the LLM response, right? But what we do here is you can specify this as being an answer output field and a reason output field. And then what this is going to do, DSPy generates this type of prompt. So does that make sense? So you follow the following format: question, context, answer, reason. So if you give, then this would be the end of the prompt that you give the LLM. Does that answer your question? Cool. Sure.
So quick question.
Recording in progress.
Is the naming of the fields is what gives the LLM the context, or?
What do you mean by the context in this?
So
What?
If we're producing the fields answer and reason,
Yep.
is this what is if I name them answer and something else, would the output be different? Answer.
It is a hint for what.
Yeah. So what you're actually calling it? So I think I know what you're getting at. So you're asking basically if I name this variable question, right? It's a hint to DSPy. DSPy recognizes that variable name is question, and it will fill in the prompt saying this is the question, this is the answer. You can give others, so in the input fields, you can give plenty of parameters as well. So you can give a hint, or you can give a prefix to the label that the DSPy is going to give it in the prompt. So there's a lot of configuration you can actually do. Does that answer your question?
Yeah, thank you.
We have one more.
Yep.
What happens if question is part of the sentence within the context that you are giving? Will it treat it differently? For example, somebody may ask a question, you say, oh no, the right question to ask is what question happens within the sentence or the paragraph. How will it distinguish?
I'm not clear on what you mean exactly. Like,
Okay, let's say you have a string of character,
yep.
or let's say some paragraph. Then question happen to be one of the word or the construct of that sentence, which is not a parameter or a label.
Sure. So I think, and so if I understand your question correctly, we're sort of talking like different levels of abstraction. So I think you're talking like if you give a paragraph as a whole context to an LLM, right? And you expect the question to be in the paragraph. How do we recognize that that's where
Like
the
what
question
is inside the input field that you are passing to question?
I could answer. It's more about like the signatures in DSPy. So the input field is actually what you want to give the DSPy as questions, and the answer is what the DSPy is supposed to give you as a back. So what's your question is more about like in the input field, which means you have a long paragraph, whatever prompt that you like, or whatever the question or the context knowledge, any kind of technique, prompt techniques or RAG that you could use, and then just fill into the input field as the question parameters that are showing on the slide. Yeah, does that answer your question?
So recursively, it will not see questions inside the input field and treat it as a separate question line.
No.
So I like to think of signatures as basically prompt templates. So if you're going off a template, right, you have some understanding of what you're going to be giving to the model, right? So you would be expecting with this type of prompt template, I'm going to be giving a question in this prompt template. I'm not going to be giving it a whole paragraph of stuff that might contain a question that I'm trying to do, right? So there is some sort of expectation that you're giving it some sort of structure on what you're going to be asking the LLM, and that's really the whole point of what the signature is, right? So we're going to see in a sec that the signatures are actually like the base abstraction that you hand to different modules, which I talk about, which can then sort of modify the prompt based off of the prompting techniques you want to use. But we'll get there in a sec. There's a question down here.
So I might be getting a bit ahead but I just wanted to ask, like, so for example, if I need to use like few shots or like one shot or something, so should I like add like a few shot, like a variable to start, or like make an entire signature or something?
So you are getting ahead. You are getting ahead. That's not what the signatures are for. But we'll get there. Signatures are sort of the base level where you're just saying, this is the template of basically what I'm going to be asking.
Okay.
Few shot, chain of thought, like those will come shortly.
Quickly about context and reason. Those are inferred, added, or you need to specify them?
Good question. We'll get there. Okay. Anything else? So this main point here is just talking about signatures. Signatures, you can think of them. I like to think of them as prompt templates. Let me just sort of explain this diagram, and then we'll get into running some actual code. So this would be an example of a basic class style of a signature, right? So Felipe just mentioned system prompts, right? And so, or sort of giving it context, and this is what this definition is doing, just that little string at the start. Well, actually, DSPy will take that and insert it just to give some context into the following prompt. We have a single input field, question, and an output field. This sort of touches on what you were asking about. So you can offer like a description for what you think this is, or for what the answer is, right? And then, not a robot. Right, and then so DSPy will take these hints, right? Prefix, questions answer, and insert this into the prompt. Point here is that these are not doing any sort of concrete prompting techniques yet. It's just the template for what you're going to be handing to the LLM. Now, okay, so building off of signatures, right? The next thing that we're going to move into are going to be DSPy modules. So this is what is actually going to be using all of the prompting techniques. So few shot, for example, there's one. Chain of thought, there's one for that. If we talk about, there's actually a list of them right here. very basic one that I'm going to give an example of first is just predict. It doesn't do any techniques on the signature. All it does is just basically hand that signature to the prompt. So if you remember, I said that you could do this inline signature definition, right? So this is just equivalent to creating a signature, single input field question, single output called answer. DSPy also sort of, DSPy will also do some, I don't know what to call them, augmentations to the prompt. So it might, give a system prompt based off of what it thinks you're trying to do. But yeah, so then you can sort of just hand the signature to the predict module, and we're able to say, ask it a question, so what is the capital of Germany? And we get an answer, Berlin. If we then want to actually see what this prompt looks like, right? So this is what the actual prompt that was sent to the LLM, just based off of that. So this is generated by DSPy based off of what it thinks you're trying to do, right? Follow the following format, question, answer, question, answer. That's the response from the LLM. Everybody with me so far? That's a simple module. Cool. Now, if we want to go for a little bit more involved prompting techniques, right? So DSPy makes this really easy. I mentioned earlier that they have like chain of thought, few shot, all that. But you essentially build what we would call these programs, right? So you'd hand the signature to different modules that use these sort of prompting techniques. Now, because I say it's a program, right? That's you sort of follow this workflow when you're developing with DSPy. So you end up collecting data, you write your program, you define some validation logic, you compile it, which we'll see in a sec, and then you sort of iterate on this process, right? So it's exactly like programming, essentially. Now, if we want to use, I'll come over to the side this time. So this one's going to be a chain of thought module, right? And so this is a chain of thought module because we're using DSPy's chain of thought. Same idea as using predict, we're just handing it an inline signature. So we question input, answer output. And then all we do when we want to actually use this module, just generate answer, right? And so DSPy takes care of all this. Yeah, so DSPy takes care of this all under the hood. We don't actually have to do any sort of think step by step, any of that sort of stuff. So we just define that. Right, yeah, and then so sort of a side note here as well. DSPy, one of the things we mentioned was compiling, right? And so what DSPy will actually do is you're able to take some examples, right? And then take your module, whatever module you might have defined, and then you can compile it to sort of have it optimized on these training examples. So this is where we can use sort of these, I forget what they're actually called. What, you might remember this. Like the bootstrap few shot, label few shot. I think they're just called optimizers. Yeah, so we'll call them optimizers for now. I might be misremembering. Yeah? Teleprompter was the one I was thinking of, yeah. Right, yeah. So these are essentially optimizers. So you can take these bootstrap few shot, labeled few shot to try and optimize your program, right? So optimize the prompt that is going to be sent to the LLM. So we'll see an example of this. So if we just give, we have this training set, right? A couple question and answers. We can take this training set. We create examples out of them, right? Using DSPy's framework. And then we can actually evaluate. We can evaluate our module based using these teleprompters, right? Yeah, because I have it called teleprompter here. So bootstrap few shot. There's different optimizers that we can use. I have some links that sort of lead to what they're actually doing. I won't talk about them too much here, just in interest in time. But you can sort of think like, essentially what's happening is DSPy is taking the list of examples that we gave it, testing these examples against the module, and then it's actually doing a student-teacher framework where it's trying to bootstrap new examples to give to the student. And it sort of does this in order to actually optimize the prompt. So we can see we're actually handing it right here, our chain of thought module, and then we're compiling it using the teleprompter optimizer on our training set, right? And so when we go to actually ask it a new question, right, we actually get this new this new output, right? Rationale, because we're using the chain of thought module. And so what this actually looks like under the hood of what's being sent to the LLM. So I'll go through this. I don't think I can fit the whole thing on the screen. But this is a result of doing the bootstrap few shot. So it's actually giving it that initial, given the field's question, produce the answer. Here are some examples, right? So DSPy is generating these examples and putting them into the prompt. Follow the following format. So because we're using the chain of thought, we have a question, reasoning. So let's think step by step in order to produce the answer. We and then the answer itself. And then this one's here is an actual example, again, of what DSPy wants the LLM to actually output. And so this was actually generated by an additional LLM call. So this rationale on why, which author is English, John Brainerd, Studs, Turkle. Let's think step by order in order to, and here we're just filling it in, produce the answer, determine which author is English, right? So DSPy is handling all this. And then an LLM will actually generate this reasoning as an example through the bootstrap reasoning, right? And it gives that as an example for what we're expecting. And then we give it the actual, and then it will actually give it the rest of the prompt for what our actual question was. So again, because we're doing chain of thought, right? We're generating this additional, let's think step by step in order to determine the capital of Germany. And then it's not great reasoning, but it works. So we know that the capital of Germany is Berlin, so the answer is Berlin. We do get the right answer still, right? So we're all good. But again, DSPy is taking care of all of this just with a simple, all we've done is just done a simple chain of thought module, question, answer, given it some examples. It takes care of compiling this prompt for us. Yeah, so I sort of just explained this. Notice how the prompt ends with a question, what is the capital of Germany? It includes few shot examples, as well as a rationale for step-by-step reasoning. For the training question, which author is English? John Brainerd, Studs, Turkle. Now, DSPy, so like I said, you want to be able to actually evaluate these prompts, right? So if you do give it a test set, or a development set, right? And we can actually evaluate our compiled prompt, or compiled program, against this new set, right? So this is just creating the evaluator. Metric is exact match. We want the predicted answer to exactly match the example answer. And then when we go to actually evaluate it, right? So what just happened was come on this side. So we just reran with our chain of thought module. We ran it on all of the examples in our development set. So you can see the original question here, so the true answer, right? This is the rationale that the model would have generated from the chain of thought, predicted answer, and whether we actually got the exact match. So this is sort of how you iterate, right? And you start comparing, for example, which prompts you think are going to start working the best. So we can see here, I think we only got, so 23.08%, which is not great, right? But this sort of gives you an idea on how you iterate along these ideas. Now, we can still go a step further, right? Like DSPy has a lot of functionality to it. So I'll do a little example with RAG query generation, and just shows how, how it abstracts everything with RAG away, so you don't have to sort of deal with all the nitty-gritty and like all the retrievers and stuff. So same example here. What we're using for a knowledge base. Sorry, Elsa, any questions following up? Sorry, yeah.
A tree of thought, can we limit it to go through a specific resource, not general data it has?
So are you asking about RAG? Or?
Here, before it's creating a tree of thought, and based on that reasoning, and you can match which prompt going better, right? I am saying, can we limit for the answers it's giving to a specific data resource, and I mean that trusted resource. Say that if you want to get the answers, go to this website and just check there, or this book.
So the answer to your question, yes. I think one of the main points here, which we'll see a bit of it with the RAG example, but so you can actually sort of, this is not supposed to be like a single call, right? So you might have different calls to the LLM saying like, go retrieve information from this knowledge source, right? And then you would say this in a variable, right? So now you have more context. You can then pass that to an additional input. Like there's nothing here stopping you from having many inputs and many expected outputs, right? So you can say like referring to this information, let's say additional context variable, right? Answer the following question only using that information, right? And we'll see a simple example of that with RAG. But the idea here is that you can, essentially we're moving towards programming, right? So you can start to do any sort of checks as well. Like, okay, did this response from this LLM meet some condition? If it didn't, we could stop, not continue, or do something else like that. And so that's sort of the idea with DSPy. Yeah? I don't know where the...
For the bootstrapped few shot, I don't understand how did it pick the, like, so for example, in the LLM inspect history, it just gave you the question and answer, like 6 of them, and then chose one of them, and it just gives a reasoning for one of them, and then it says like for the next question, create a reasoning and stuff.
Yeah, so good question. So maybe before I get into Bootstrap FewShot, I can talk a little bit about labeled FewShot, because Bootstrap FewShot is sort of the next level of labeled FewShot.
Okay.
So labeled FewShot, sorry, I'm just trying to figure out where I am here. Yeah, here. So like this is what you're talking about, right? Yeah. So if we talk a little bit about labeled FewShot, right? So labeled FewShot is just going to be giving it like a labeled FewShot, right? So you give it the examples and it'll select. It's a configure. So that's a configuration parameter. Like how many examples do you want to give the prompt? That's a configuration parameter. But so you have these examples, right? And you're just giving them to the model. Bootstrap FewShot. So you'll notice when we went to compile it, right? So we bootstrapped one full trace after 7 examples. What's actually happening here is DSPy is trying to generate a rationale, because it's chain of thought, for the prompts, and then it will take the rationales as examples that led to a correct answer, because this is the training set, right? Yeah. So this is why we only have one. So it only got one good chain of thought that led to the correct answer. So that's why we only end up with this single example, right? Because that's a good example, right? So that's what's going on with the bootstrap chain of thought.
It's still going to give you the, like, without the reasoning, it's going to give the other examples.
Yeah, these are all actually like, they're all configuration parameters for the bootstrap metric. So max bootstrap demos, right? 2. So we would only, if we had, for example, 4 successful traces, 4 successful rationales, we would only still take 2. So these are all like configurable, right? Cool. Anything else?
And for labels, it's just going to give you like the original ones. Like
Yeah.
No rationale.
Yeah. So that's actually I forget what the concrete parameter is here actually, but yeah. So max labeled demos here is 16. So these are the raw. These are just basic labeled rationales, right? So if we had more examples, the max would be 16 because we didn't configure it, right?
And it chooses randomly or like based on some?
I'm not entirely sure how it actually chooses. Yeah, that's not something I'm completely sure on. Maybe there's some evaluation stuff if it's like a harder, or if it's like a more involved, what do I say, like compare like whether something's right or wrong. Here we're using, is it exactly correct? Right, so it's binary, but yeah, I'm not entirely sure on that. Anything else? Okay, we're just in interest of time. We'll come down to some of the RAG stuff. Right, okay, so I'll quickly go through RAG with DSPy, and this will be a good example of how we can build programs using DSPy's framework. So here for the knowledge base, right, DSPy has these different like abstractions that you can use. Here, what we're doing is just pulling the first paragraph of Wikipedia pages, so abstracts from 2017, right? So this is what our knowledge base is. And we can sort of see this. So DSPy or DSP.retrieve, what actor played Harry Potter, get 5 responses. So this is the knowledge that comes back from DSPy. So list of Harry Potter cast members, Daniel Radcliffe, this one looks wrong. Daniel Radcliffe, this one looks wrong. So it's not doing any, it's just trying to get the knowledge from our knowledge base. But if we want to sort of integrate this into DSPy, right? So we're going to actually build a new program using this knowledge base. So we can see here when we actually go to instantiate this RAG program. So we use our retriever, and we want to get X or K number of passages. We then generate a query that's using DSPy's chain of thought, right? So based off of a question that we're going to end up giving it, generate a search query to search our knowledge base for information that might answer that question. And then we're using it again to generate the answer. So given the context we might have received from our knowledge base and the same question, generate an answer. So that's sort of how we're using. So this we can see, we're again using different signatures, inline signatures, to build these modules, right? Both cases we're using chain of thought. And then when we actually go to call our program, right? So we're going to generate a query, which is what we instantiate right here, and then retrieve the passages from our knowledge base using our query, and then generating an answer using the context and the question. Does that make sense on how we're sort of building up these programs with these prompts? Cool? Oh, sorry, yeah.
How we evaluate the generated one is accurate? Does it give you?
So how do you evaluate whether the generated query is accurate?
Accurate.
So it's going to end up, what it's going to end up doing is trying to, how do I say it? So when we go to compile this program, right, we'll do it on a set of training examples. And what it's actually going to do is try and optimize its query generation and its generated answer that leads to a good answer on the training, right? So there's different, I'm not going to talk about it in the notebook, but there's different optimizers, teleprompters that essentially like, so for example, one of the signatures is modify this prompt that would lead a language model to generate a good query. So it's sort of like, this is what DSPy is doing under the hood. And it's sort of just generating prompts, testing them out, and finding which one actually works best with the training data you have. Does that make sense? Yep.
For the RAG part, is it like, in the start, I think so when you added Colbert, is it there when you set the RAG module or the RAG model? Because in this class, you didn't specify where the retrieve is coming from.
Oh, sorry. So it's because I'm configuring it right here, right? Okay. So I reconfigure DSPy to, instead of only use an LLM, to use a knowledge base. Cool. And you'll see at the top of the notebook, when I go to instantiate the LLM, I do the same call. I just don't give it the retrieval model. So there's no retrieval model like instantiated at that point. Oh yeah, sure.
I kind of had the same question. Is that the normal or only way to do it?
No, so you can do it. There's a couple ways to do it if you want to. I'm blanking on the name. Like with retriever as retriever model, do this. So you can do like have multiple of them going at once if you want to. Okay. Or you can. There's different ways to configure it. Yeah. Configuration. Yeah. Okay. Here I'm just being like using DSPy here. Just configure it to always use it. Anything else?
The server seems to have an issue. I mean, it's all with your caching, but if you follow the URL, you get a strange JSON.
Oh, yeah. So it's because it's, yeah. the server is, yeah, it's the URL's there because it's cached. Yeah. Okay. Let me just see where, yeah, so this is where we're actually, to sort of start to answer your question over here about optimizing the query. This is where we actually go to evaluate first our base model. So this isn't any compiled, it's just giving this prompt to, the LLM without any sort of optimizations. And then, it's just standard prompting at that point. But if we go to compile it with, here, for example, bootstrap few shot with random search. When it's going to bootstrap the rationales, it's just doing a random search, right, to try and find good examples. But when we go and do that, we actually get, once we come down here, so 11 candidate programs found. So what it's doing is trying to search different programs, different prompts that do well with the training set we have. And then when we go to evaluate this final compiled RAG, so we'll see that we actually get quite a bit, double the improvement actually. So up to 46%. And so it's doing quite a bit better because it's getting all this knowledge base, using all this knowledge. And if we actually look at what the prompt that's being sent, right? Let me just scroll up here. So this is all the same, right? So given the question, produce the answer, field context question, produce the answer, use the following format. But then here we can see this is what the retriever actually got from our knowledge base based off of the query that it had. So the question, so which award did the first book of Gary Yukov receive? This is some of the context it retrieved, and then this is the reasoning and answer. Now keep in mind, this is just still the bootstrapped example, right? So this is just the one example we're using. In terms of the actual query that we sent, what year was the party of the winner of the 1971 San Francisco mayoral election founded? The actual context that it retrieved was this information right here. The reasoning, this was again generated by the model. So the winner of the 1971 San Francisco was a member of the Democratic Party. We also and then so it goes through this reasoning, and then therefore this is the answer. And so this is sort of the starting point of where you sort of build these prompts into these programs, and you can sort of mix and match and build these workflows and optimize things that are happening. Like I said, there's other different optimizers that you can use. So just trying to optimize the prompts that's being sent to the LLM to get the best answer for your data. And so it's moving towards a much more engineering perspective, right? It's no more, it's not, I think I called it vibes-based development, which was a good thing I read on a blog, which is really, I don't like that at all. And so this is a good way to move forward. It's a lot of fun to play with them too and look at the prompts that it's generating. And then actually going into the implementations of the modules to see what prompts they're using to get the LLMs to generate better prompts, right? And so it's kind of interesting to see okay, what works, what doesn't, that sort of thing. So that was DSPy. Any other questions, comments? If not, I think, so we ended with just a high level thing on RAG. Justina's gonna go into a bit more detail on how RAG actually works.
Yeah, sure.
Yeah, okay.
Thank you, Ben.
Cool, anything else? Good to go? Thanks.
Yeah.